This video is going to cover lesson 4.3, which covers side, 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 also known as SSS. The other day, you watched a video from section 4.2, and you learned that in order to show that two triangles are congruent, you had to show that all 6 pairs of congruent parts were congruent. So in doing that, you had to show all 3 angles were congruent, and you also had to show all 3 pairs of sides were congruent. Now, we worked through a problem about doing that in class as a part of class the next day, and we found out that it was a very, very long process because you have to show so many congruencies. So what we learned through the rest of the unit is that you actually don't need all 6 pairs of congruent parts. You actually only need 3. Depending on what 3 pairs you're able to find will tell you which congruence postulate or theorem that you can use. Today, the first one we're going to deal with is called SSS. SSS is a theorem or postulate you would use if you're able to prove all 3 pairs of sides for the 2 triangles are corresponding congruent pairs. So as we move down, you can see this is your definition or your explanation of your postulate. Notice that you have 2 different triangles, and in each one you have corresponding parts that are marked congruent. So MN and RS, congruent pair of sides. You've got NP and RS, a pair of congruent sides. And the last pair, MP and QS, are a pair of congruent sides. Therefore, we are able to say that the triangles are congruent, and the reason why is by SSS. So what we're going to use is that as a reason for the last step of every proof that we're going to do in congruent triangles in this section. Now, is it the only pair or the only congruence theorem we'll learn? No, there are actually 5 total. So this is the first of 5. So down here, we're going to look at some pictures, and we're going to try to show whether there's enough information in the picture to say that we have congruent triangles. Now, not every problem is going to be a proof, so these are examples of ones that aren't proofs, but we're still doing the same type of thing. We're still showing whether or not the triangles are congruent. So remember, in order to use SSS, we have to show all 3 pairs of sides are congruent. In this first picture in number 1, 2 of the pairs of sides are already given to you. So we just have to find a third congruent pair. Now, if you look at the way the 2 triangles lay, they actually share this third side, JK. Since they share that third side, they can actually be said that that third side is congruent to itself. Anytime we say something is congruent to itself, that is called the reflexive property. So if you wanted to write that down as that's my third congruence, this is what it would look like. So if you look at what I have illustrated, in each triangle you have 3 pairs of congruencies. You've got side HJ and JL. You've got side HK and LK. And now you also have side JK and JK. Since you're able to show that you have 3 congruent pairs of sides, you can say that the triangles are congruent, and you can write a congruent statement. So remember, when you write a congruent statement, you're able to write the first triangle in whatever order you want. So I'm going to write it in alphabetical order and go H, J, K. The second triangle just has to match that same order. So how can you tell the order when you're looking at the 2 triangles? Well, notice that HJ were the first 2 letters, and if you look up at the triangle, they are also this purple side now that I'm shading in blue. So what we would want to do is put these 2 letters first because that's the side length that matches with them. So I would start with L, go to J, and then finish at K. And that would be my congruent statement, and underneath I'm going to write that I'm saying they're congruent by side, 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 because I was able to show that all 3 pairs of sides were congruent to each other. As we move through the unit, we're going to add more reasons, and that's why I'm specifically saying SSS now. So when we start throwing in things like SAS, ASA, and so on, we're going to have to write down which one of those congruence theorems or postulates we're using at that time in that problem. This one right now, every one of them is going to be SSS if we're able to say congruent, because it's the only one we've learned so far. Now, if we move on to number 2, in order to show that you have congruent triangles right now, we have to show we have 3 congruencies. Well, right now we have 2. We've got the sides I highlighted in blue and the sides I highlighted in purple. Now, if you look at the third pair of sides, be careful. Yes, they look like they're the same length. However, remember in geometry, because it looks like it is not a valid reason. Therefore, I would have to come up with some kind of reason, like they're shared sides, so reflexive property. Or I've got a midpoint, so I know they're congruent. Or I've got a bisected side, so I know they're congruent. Think of all of the different things that we've learned this year so far that would have allowed you to say that I've got congruent line segments. Now, in this case, none of those things are true, and therefore we're going to say that there's not enough information in this picture to prove that the triangles are congruent. Now, I'm not saying that they aren't congruent. I'm saying that there's not enough information in the picture to say that they are. There's a difference between those two things. In the next one, number 7, again, notice that we've got 2 pairs already marked, DG and EG. We've got DF and EF. And the third side, again, just like the one above, comes from this side that's shared down the middle. So I'm able to say that that is a third congruence, and therefore I have congruent triangles. So side length GF is congruent to itself. And again, anytime something is congruent to itself, that's called the reflexive property. That was my third congruence that I needed, and therefore I can say that I have congruent triangles. Remember, when you write a congruent statement, the letters for the first can be in any order, so I'm going to label them in the order D, F, and G. The second triangle is the one that has to match it, so if I do these in order, we're going to go E, F, and G. And again, underneath, I'm going to say that they're congruent by SSS, because I was able to show that all 3 pairs of sides were congruent. In the next problem, notice that AB and CD were marked congruent for me. They gave me 1 pair of sides. It's my responsibility now to find the second and third pairs. If you notice, AC down the center is a shared side, so that is a second pair. However, there's nothing in this picture that would allow me to connect AD and BC. There's nothing that's shared between the two of them. There's nothing about a midpoint or bisecting line segments or anything like that that would allow me to say that they are congruent side lengths. Therefore, in this picture again, there's not enough information. And again, I'm not saying that the triangles aren't congruent. I'm just saying that there's not enough provided information to say that they are congruent. And there is a very big difference between those statements. On the back of this, we get into a couple of full-blown proofs. So what we want to talk about in these proofs, so what we're going to do first in any proof is obviously take our given statements, and we are going to write those right here in step number 1, obviously, as given. So when you look at what's given to you, in your given statements, there are no given congruencies. Now, I'm looking at my given statements. Okay, there's no congruent or given congruencies. Therefore, it's going to be my responsibility to provide all of the congruencies that I need to show that my triangles here are congruent to each other. So let's start off with the fact that we only know right now side, side, side. Since we only know side, 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 the thing I'm looking for in this picture is there a way to show that all of the side lengths correspond and are congruent to each other? The first set of side lengths I'm going to start with are the ones that the book has already marked for you, which I don't like that they did. So in step 2, we're going to write that AR and GR are congruent side lengths, and here's the reason why. You're told that DR bisects AG. And anytime we see that word bisects, we know that means we have two congruent pieces. Those congruent pieces in this case are AR and GR. So therefore, I'm using the definition of bisect to say that they're congruent, because that's what bisect means, congruent pieces. The next congruency I'm going to point out is this shared side down the center of the two triangles. That shared side is a second pair of congruencies in my picture. So I'm going to state in step 3 that DR is congruent to itself. Anytime we make a statement about something being congruent to itself, whether it's a pair of side lengths or whether it's a pair of angles, we're always using the reflexive property. That's a property we learned a couple of units ago that says anything is congruent to itself. Now, if you notice from my picture, I now have 2 of the 3 congruencies, and here's where the last one comes from. Notice it says that the overall triangle, ADG, it is an isosceles triangle. ADG is this entire big triangle on my picture. And what it means to be isosceles is that you have 2 sides that are congruent in this big overall triangle. Those 2 congruent sides just so happen to be AD and GD, which means that that's my third pair of congruencies. So I'm going to write in step 4 that AD and GD are a congruent pair of sides. And now I have to come up with the reason that I know they're congruent. The whole reason I knew is because of this word isosceles. Since I know the triangle is isosceles, the definition of that tells me there are 2 side lengths that are the same, so I'm using the definition of an isosceles triangle. So now in conclusion, if we look at the overall picture, just like on the front, we were able to mark off that I've got 3 pairs of congruent sides, which means that yes, I can now say that my 2 triangles here are in fact congruent. So step 5 is going to be to make that statement. Triangle DRA is congruent to triangle DRG. And here's where it's going to be important that you know when we throw in all of our extra congruent statements and postulates, what do I put in my last step? Well, if you look at the 3 steps you've done, 2, 3, and 4, in each one of those, we were able to prove that the sides were all congruent. Therefore, we're using the theorem or postulate side, side, side. So I simply write in step 5, SSS. As we add more and more of these congruence theorems and postulates, this 5th reason will change depending on what these steps were when you proved your congruencies. The last problem on here, again, is another proof. So the first thing we're going to do is take our given information, and we're going to put it in the proof. Next thing I want to do is I want to look and see, did they give me any congruencies to start? And they did, in fact. They told me that FJ and HJ were congruent, so that's already a statement that's in my proof. I don't have to restate that. So my responsibility is to find the last 2 congruencies. So looking at your picture, you always want to look for the most obvious pair. That obvious pair in this case is the fact that my 2 triangles share that center side again. So I'm going to make a statement that JG and JG are congruent to each other. Since it's a shared side, that's called the reflexive property. So that actually gives me my second congruence, and my job is only to find one more. So what you want to pay attention to now is what's in the given. It says that G is the midpoint of FH, and so we're going to look at G as the midpoint of that side length, which, if you remember what midpoint means, it means that it's directly in between F and H. So what that means is the distance from F to G and H to G is actually the exact same. So we're going to make a congruent statement saying that. We're going to say that F to G is congruent to H to G. And again, we know that because of the definition of this word. So my reason, definition of midpoint. Now, if you look at your picture, notice that we have now marked all 3 pairs of congruent sides. Therefore, I only need 3 congruencies, and so I can go ahead and now state that I have congruent triangles. So I'm going to recopy my prove down here as step 4. So triangle FGJ is congruent to triangle HGJ. And the reason why, again, in this lesson alone, SSS is the only congruence theorem or postulate we have currently used. Therefore, the only reason I can put here is SSS. I proved all 3 sides were congruent. They gave me 1 in the given. I was able to prove 1 because it was a shared side using the reflexive property, and the third side because I had the definition of a midpoint. G was the midpoint of FH. So I got all 3 pairs of sides congruent, and therefore the triangles are congruent using SSS. If you have questions or things that did not make sense in this video, make sure you make a little list so that you have specific questions you can ask next class.